Hey everyone, Laz here from Adatis, and today we'll be going through the final part of a three-part video series all on Power BI performance tips. So if you haven't seen part 1 or part 2, be sure to click the link up here and then jump back to this video. Otherwise, let's look at the final set of 3 tips that should help you see better overall performance. And just to call it out of all the tips in this video series, the last tip in this video is by far the most important tip to follow when building Power BI solutions. So be sure to stay to the end. So continuing with tip number 7, which is to disable the option allow data previews to download in the background. Now, to be clear, I am not saying to do this at the beginning of building a solution, right? This is actually a helpful feature for when working in Power BI desktop. However, when working on a Power BI solution with multiple queries, and that's the key here, with many queries in Power Query, you might find after you click the refresh button, your solution starts to lag on maybe the evaluating status. So this tip here can help speed up your refresh time if you have loads of queries in Power Query. But let's go ahead and check this out. So we are back in Power BI desktop and we are connecting to some data from an AdventureWorks database, as you can see. Now, before I go ahead and show you how to disable this option, I first want to show you what's happening in Power BI, which may call for us to disable this option of data previews. So when we go ahead and click the refresh button up here, what we would think is Power BI is simply refreshing all our queries which are in Power Query. Okay, so if we select refresh, Power BI is simply refreshing all these queries here in Power Query. Okay, and this does happen. So I'm now going to go ahead and click on the refresh button, and notice it tells me the names of the queries, right? And we can see everything is now being loaded as expected. However, Power BI is also loading and storing in memory the top 1000 rows for every query, and this is used to preview the data to us in Power Query. Okay, so to show this, I'm going to go back into Power Query by selecting transform data, and notice that for every query that we have listed here on the left hand side, Power BI shows us the top 1000 rows, which is super helpful, right? But when our Power BI desktop solutions contain many queries, don't look at my one here, I'm just using an AdventureWorks database, right? I've worked with other solutions that had many more queries, and of course when we have this, retrieving and storing the preview data in memory can extend the overall time it takes to complete a full refresh. And for this reason, if we have many queries here in our Power BI solutions, we could go ahead and explore turning off or unchecking this option. So I'm going to close down Power Query. I'm going to go to File, Options and Settings, Options, and under Current File, I'm going to go to Data Load. And notice by default, we have something called allow data previews to download in the background as checked. So let's now go ahead and uncheck that and click OK. And now if we go ahead and click the refresh button, even though it looks like nothing different is happening, Power BI is no longer loading the preview data, which is used for the top 1000 rows for every query. Okay, so now that we did that, if we came back to this over time and we refreshed, you'll see a yellow banner on the top here notifying you that the preview hasn't been loaded for or refreshed for a certain amount of time. So again, an important note just to keep in mind, the downside to this is the preview data can essentially become out of date. And what we will have to do is essentially go to refresh preview and then do refresh preview for the individual query, or select refresh all. We are now on the 8th tip, and that is to question calculated columns. So what do I mean by this? Quite simply, let's use measures before using calculated columns, and let's only use calculated columns if they are actually necessary. So with that said, let's go ahead and check out what we mean by this. We are back in our Power BI solution. So when we need to create some form of calculation in addition to the data we already have in our model, we can either choose a calculated column, or we can actually go ahead and choose a measure. So we can see here, we can choose new measure or new column, which essentially is a calculated column. Now, too many times I find calculated columns being used before measures, and the reason for this is users prefer them as they can physically see them being created when we select this, okay? So let's say we need to create a new measure called total sales. I'm going to go to the data tab. I'm going to select our fact internet sales, as that's where we want it to be. And now what we're going to first do is we're going to select from table tools, new column for a calculated column, okay? And notice as soon as I select new column, what happens? Power BI physically adds an additional column at the end of our selected table, which of course was fact internet sales. Okay, so let's go ahead and add our formula in here. So I'm going to call this sales equals order quantity, and of course we need to multiply that by unit price. There we go. Okay, and now I'm going to go ahead and select the tick to save that. And I find many people prefer this, the process that we just saw, as again, they can see it happening. You can physically see the table has been added here, and it feels more like Excel. So it feels more like what users are used to doing by working in Excel in the past. But here's the problem. As calculated columns are physically stored in the model, right, as we just saw now, they are physically stored on this table. They are consuming our precious memory that we should try to reserve, essentially, okay? So one thing to be clear though, if we have a couple of calculated columns, 1, 2, 3, 4, that's fine, right? Of course, this won't be a massive issue. But if we have a solution that needs tens or hundreds of calculations and we are only using calculated columns, this is when we may get or sort of start to see some performance issues, okay? Also, another thing I like to call out with calculated columns is they work on something called row context. And that means that each row is iterating over the entire table in order for this to be calculated, okay? So it starts here on row 1 and it evaluates the expression for every row until the last row. So it goes all the way down up until the last row, which is 54,771. So it has to go through the entire table when using calculated columns, okay? So instead of using a calculated column, let's go ahead and select a new measure instead. So I'm going to go back to table tools and I'm going to select new measure, okay? And notice, right? As soon as you selected new measure, it didn't take you to the end of the table and shows you a column physically being added, okay? And that's fine. We can still go ahead and create what we need and we'll still get the result that we want. I guess the reason for this is a measure will be processed, right, at the point of interaction. So by this, I mean, when we drag it onto a visual, that's when essentially it will start to be processed. So let's go ahead and now create, again, sales. And I'm just going to call it measure now instead. And to calculate this, we want to do a sum x over fact internet sales, right? We want to iterate over that. And then we want order quantity times unit price, exactly as we had it before as well. So now I'm going to go ahead and click save that. So if I now go back to my report canvas over here and I drag in our sales measure, as you can see, there we have it. We have our result returned to us, and you can see over here it's 16.3 million. Okay, and if I go ahead and drag in our calculated column, it gives us the exact same thing once again. So to summarize, let's not use calculated columns simply as the default to derive additional calculations in our models, okay? They should be used correctly, such as if we maybe need to use them in a slicer or a filter, as this can essentially reduce memory consumption. It could improve refresh times and enable publishing Power BI solutions to the service that were previously exceeding the 1 GB limit if you're using a Power BI Pro license as well. We have made it to the final tip of the 3-part video series. And as I said at the beginning, this is the most important tip of them all. So if there is one thing you should do, is this, and that is to align your model as close as you can to a star schema. So a star schema is essentially a data modeling approach whereby we structure our data into facts and into dimensions. Now, all our numerical attributes will be in our fact table, and all our descriptive attributes will be in our dimension table. Now, the big question may be, why should we do this? Well, it offers better performance, it enables more capabilities, it makes our Power BI solutions more scalable, and most importantly, it keeps everything simple. But there is so much we can talk about here, so we are briefly going to go through the basics now, and I will have a separate video that is dedicated to building a star schema in Power BI. Anyway, let's go ahead and check this out. So we are back in Power BI desktop, and here I just prepared a solution for us to showcase star schemas. So as we can see in our current model, we have some dimension tables. So we have calendar, customer, territory, product category that all should contain descriptive attributes, right? The only other thing apart from that should be a primary key to establish a relationship back to the center table, which is our sales fact table that should contain only numerical attributes for deriving measures, right? So with that said, let's say I want to go ahead and view our sales by product category and also product name. So I can go to sales, and in sales, I'm going to drag in sales amount. And then of course, product category makes sense to be under product category. We'll drag that in there. And there we have it. Already we're getting the result that we want. So we have the breakdown of sales by product category. And like we said before, we also want to have our product name. But notice that even though we have product category, we don't have a product dimension here. Now, what's happening is all our attributes or columns relating to product are in fact stored in our fact table. And this is a common case where you would come across, right? This is how the data may have been given to you, or you might just be working from a flat table, right? Where all the columns are just stored together. So you can see in here, we have attributes like the ones that we've added, sales amount as expected, but we also have product name, model name. We also have things such as color, and these are all product attributes. But anyway, I can actually still go ahead and drag product name onto our visual, and let me just make that into a table for now. And notice the data is still being returned, right? So it still gives us the data that we want. However, we do want to push this and align it as much as possible to a star schema approach for all the benefits I mentioned earlier, right? So with that said, we want to go ahead and remove it from here. The last thing we also want is our users to have to scroll up and down through a long fact table just to find attributes relating to product, okay? So to do that, I'm going to go ahead and delete this visual, and I'm going to go to transform data to take us to Power Query. And here is where we are going to start aligning our model closer to a star schema. So like we said, the first thing we want to do, everyone, is we want to remove everything relating to product from the sales table and put it into its own dimension. Okay, so the way I always start, I first have a little look at what are the available columns in here. So the best way to do that, I always like select and choose columns rather than scrolling left and right down here. It's a lot easier. And you can see that we have various different columns in here as well. So you can see one's already unselected. So what's happening here? Well, everything from order date key, which is right at the top over here, all the way down to freight, which is this one here, all this actually relates to sales, okay? But from product name, which is over here, and everything below this, everything here actually relates to the product or our product dimension. So we want this to be in its own dimension. We want everything from product name and downwards to have its own dimension table. And to do this, what we're going to do, we're going to cancel out of here. I'm going to right click on our sales fact and click duplicate. And once we've clicked duplicate, the first thing we should always do is rename it. So as is our product dimension, I'm going to call it product table. Okay. The next thing I want to do, now that I'm aware of which columns should be removed, I'm going to go ahead and select those that should be removed. So I know it was everything we said up to freight. So I'm going to select remove columns. And now I know that everything that remains in here relates to product. Okay. So the next step is to actually go ahead and make this unique. So what do I mean by this? I mean, in the product dimension, or sorry, in any dimension, every row should be unique. So in other words, here, every row should uniquely represent an individual product in the AdventureWorks database. And notice here, for example, you have Road 150 red 44, Road 150 red 44. This is a repeat, right? We don't want that. So I'm going to select product name and make sure you select the column first, right? Right click on that, and we're going to go ahead and select remove duplicates, right? So now that we did that, notice on the bottom left here, it says we have 19 columns as we did before and 130 rows. So in other words, we have 130 products in our AdventureWorks database that customers could purchase, okay? So now that we did that, we have our product dimension. And in fact, many people might just stop here, right? We can actually go ahead and say, well, you know what? I'm going to click close and apply. And I'm going to establish a relationship with product name from product dimension and go back to sales and establish a relationship with product name here, right? But this is not what we want to do. In fact, what we want is to ensure that we're using integers before strings, and this is something that I spoke about in part 2 of this 3-part video series all about Power BI performance tips. So I would suggest you go ahead and check that out if you have any questions as well. But anyway, instead of doing that, what we want to do is derive a primary key, which is an integer column. And to do that, we can simply go to add column. And then under add column, you'll notice we have something called index column. I'm going to select the drop down and I'm going to select from 1. And notice Power BI has now essentially given us this counter column or an ID column that essentially starts from 1 and then goes all the way down to the last record in this table, which is 130. And now we have 130 assigned against Turin 3000 Blue 62. Okay, so that's what we're doing here. We're deriving a primary key. So I'm going to call this product ID. And we can now see, and actually what we should always do, or I like doing, is move to beginning. So we can now see that Road 150 Red 62 is represented by 1. Mountain 100 Silver 44 is represented by 2. And so on and so on. And again, we may think we can stop here, but one last thing we should try do now is take the product ID and take it back to the sales table, or derive it in here too. After all, we must be able to establish a relationship with the primary key to a foreign key. So to do that, what we need to do, we go to our sales query, as I have now, and we're going to go ahead and select merge queries. And notice in the merge queries dialog box, we need to select another table in here. And of course, we need to select product, right? Because we're merging sales to product for the purpose of deriving product ID into our sales table. Okay. However, how do we actually go ahead and tell Power BI or tell Power Query how to essentially understand which roles relate to which roles from each other? And we need to have a common field, and the common field here will be product name, as I've selected here now. And this is the reason, by the way, we haven't deleted the product attributes from the sales table yet, right? We want to wait until we merge the primary key from our dimension table back to the fact table before we remove all the columns relating to product. So now that we've done that, we're going to leave it as a left outer join, which makes sense. So I want everything from sales plus everything that matches from the second one. And then here, we're going to go ahead and select OK now. And we're now going to have this additional column right at the end. And if we select this sort of two-sided arrow, Power BI is telling us, okay, so I understand you want to merge sales to product based off the product name. What would you like to return back? And of course, the only thing that we want back in here is the product ID. So I selected product ID, and I'm going to go ahead and select OK now. And there you have it, right? So we now have our primary key, product ID, derived into our fact table. So this will now be a foreign key. So I'm going to also move this to the beginning. Okay. And now that we've done that, I guess the last step now is, well, we don't need all these descriptive attributes in here anymore, right? We don't need everything from product name all the way down to product category key. So I'm going to go ahead and remove all these. And now, here's the beauty of it. We only have integers in our entire fact table, and that's exactly what we want, everyone, right? Our fact table will be our largest table, and again, we want to promote the use of integers over strings due to how Power BI compresses them. So again, you can see more about that in a previous video in part 2 of this video series. But anyway, now that we did that, we can go ahead and essentially click close and apply. So let's go ahead and do that. You can see it's loading product and sales because that's where we've made changes essentially. And now if we go to our model, here we have our product dimension. So what I can do here, I can establish a relationship from product ID to product ID, and that's what we want. A one-to-many relationship from product to our fact table. And then of course though, we have our product category as well, right? And keep in mind, we actually deleted everything to do with product from here. Hence the reason this relationship got removed. So what we could do is, well, we have product category key. I could actually go ahead and look for product category key in here as well. There we go. And establish a relationship. And this would work, right? Showever, this is more of a snowflake schema, not a star schema, right? And again, even though this would work, we should try our best to stick to a star schema approach. So let's go ahead and resolve this last step here as well. So we're going to go back to transform data. And in transform data, we are essentially going to take all these attributes, well, it's not that many, there's 4 records, right? So we have bikes, components, clothing, and accessories. We want to take this English product category name, so the description, and we want this to be added in the product table, right? So then we have one dimension relating to product and everything is included in here. So to do that, all we have to do is, again, as we did before, select product. We're going to click merge queries because we want to bring in here some additional columns from product category. And then I'm going to select product category in that case. And notice, like we did beforehand, we actually made or established the common field, between the 2 tables of sales and product was product name. But here we actually do have a key already. So I'm going to select product category key and scroll all the way to the bottom, product category key. Again, notice that we're going to leave left outer, so all rows from the first and anything matching from the second based off this common field here. Click OK. And then I'm going to go ahead and select English product category name. I don't want to use the original column name as a prefix. And there you have it, right? We now have the English product category name in our product table. So what we could do, we could go ahead and click close and apply. But before we do that, we're also going to right click product category and we're going to uncheck enable load. So if you have any questions on why we're doing this here, again, if you look at part 1, part 2, we do highlight the importance of unchecking enable load when necessary and how this can help overall performance and reduce memory consumption as well. So I'm going to click continue there. And then I'm going to go ahead and click close and apply. So let's just give that a moment to load as well. And there you have it. Our model is now aligned to a star schema. So we saw how Power BI gives us the ability to align our models as closely as possible to a star schema approach. So if I now go back to the report canvas, I can go to sales and I can drag in sales amount. And again, look how easy it is now. There's no need to scroll up and down. It's a lot easier to find the columns that we need. And also if I go to the product dimension as well, in here I have my product name and then also I have my product category name once again. So again, following this approach just makes it a lot easier essentially to use our model as well. We have arrived at the end of our 3-part video series. I hope you found all these tips useful and they help you with optimizing your Power BI solutions. If you have any questions, do feel free to add a comment or reach out as well. So until the next video, take care.